This is going to be a delicious one. Yes, we are talking about Cauchy-Schwarz inequality, which is popularly known as CS inequality. We shall cover it in two parts. The proof will be given in the second part, and in this part we shall mainly learn how to unfold the problems by using Cauchy-Schwarz inequality. Make sure no one disturbs you for next 10 minutes. Don't get me wrong, but it is the time to close your door and use your earphone. In this video, we shall see another version of CS inequality as well, that is popularly known as T2's lemma. Let's get started. First, let's see the statement of CS inequality for two pairs of real numbers a1, a2 and b1, b2. That is, modulus of a1, b1 plus a2, b2 is less than or equal to square root of a1 square plus a2 square into square root of b1 square plus b2 square. And the equality holds if and only if a1 is equal to kb1 and a2 is equal to kb2 for some real number k. In other words, the equality holds if and only if the ratio of a1 and b1 is same as of a2 and b2. Similarly, for three pairs of real numbers, we have this result. If you are learning CS inequality first time, I recommend you to take your notebook out and write this inequality yourself. You will understand it better and quickly. Don't stare at the screen. The general statement of CS inequality for n pairs of numbers is modulus of a1 b1 plus a2 b2 up to an bn is less than or equal to square root of a1 square plus a2 square up to an square into square root of b1 square plus b2 square up to bn square. And the equality holds if and only if a1 over b1 is equal to a2 over b2 up to an over bn. Let's see the strength of CS inequality in this example. We immediately conclude that the maximum value of modulus of a sin x plus b cos x is square root of a square plus b square. Many of you might have read the proof of this result in trigonometry as well. Notice that the CS inequality proved this result instantly. Feel the strength of CS inequality. But strength always comes at a cost. The hard work we put in proving the CS inequality is the actual cost of this instant proof. I would like to digress for a moment and want to explore this point further. It is the nature of mathematics that when we are equipped with stronger tools, we are able to solve old problems in lesser time in comparison with elementary methods. But remember, this does not diminish the importance of elementary methods. The charm of solving some geometry problem by using elementary methods is far superior than solving it by advanced tools like vectors or calculus. But sometimes the elementary methods are so cumbersome or even incapable to solve some problems, then we have no choice other than advanced tools. In fact, such problems are the reasons we dig deeper and deeper and seek some breakthrough. That is how we invented calculus or linear algebra, for example. But in the perspective of problem solving, you should explore many solutions and should ask yourself which method is better and why. Use the tools wisely, not blindly. I have personally seen many students who blindly use derivatives when they get a problem on finding the range of some function. They think that the derivatives is the only tool to tackle such problems, but it is not the truth. We can pose problems whose solution based on calculus is complex, mechanical and dull in comparison to elementary methods, which gives imaginative and beautiful solution. For example, try out this nice ISI problem from my book Algebra Volume 1. So finally, the crux of the whole discussion is what I just said before, and I repeat, use the tools wisely, not blindly. Now let's come back to the CS inequality. Let's take the first example. What a coincidence! I was just advocating non-calculus solutions to find the range of some function, and we get the problem on finding the maximum value of the function fx is equal to 3 square root of 2x minus 1 plus twice square root of 5 minus 3x. Definitely we are not going to use calculus. I can assure that the derivative will make this problem ugly, and I am sure, like me, you are a devotee of imaginative and beautiful work. Otherwise, there is no reason to stick with me so far. So we are going to use CS inequality. Let's see what we can do with CS inequality in this problem. We can quickly observe that fx can never be negative because it is the sum of two non-negative numbers. So modulus of fx is equal to fx. And now we can apply the CS inequality. That gives fx is less than or equal to square root of 13 into square root of 4 minus x. But this is not a constant value. So what should we do now? Can we apply CS inequality cleverly that serves our purpose? The answer is yes. Our goal is to make the RHS a constant. So we manipulate fx in this way and then we apply CS inequality. This time we are getting the RHS constant. We are getting fx is less than or equal to square root of 35. Can we conclude that the maximum value of fx is square root of 35? The answer is not now. We have to actually show that there exists some x for which the equality holds. And the equality holds if and only if these two ratios are equal. That gives x is equal to 6 over 5. But there is one more pitfall we have to fix. We have to check whether 6 over 5 lies in the domain of fx or not. So the question is, what is the domain of fx? It is easy to find, that is the interval from half to 5 over 3. And we are lucky that 6 over 5 lies in the interval. Now we can safely say that square root of 35 is the maximum value of fx. And this completes the solution. If the video is helpful for you, then why are you hesitating to hit the like button? Hit it now. Making such amazing videos requires a lot of efforts. Your one token of appreciation motivates me to produce more quality work. So be vocal to give your opinion in the comment section because it matters a lot. Let's move on. We have another version of CS inequality that is popularly known as T2's lemma. In fact, this version is more popular than the original one because it is used frequently. This is the general version of T2's lemma. I repeat, if you are learning it first time, make sure you write it yourself. Notice that the difference that in the previous version, both AIs and BIs can be any real number. But in T2's lemma, BIs are positive. Let me read out the statement for you. For real AIs and positive BIs, we have A1 square over B1 plus A2 square over B2 up to AN square over BN is greater than or equal to A1 plus A2 up to AN whole square upon B1 plus B2 up to BN. And the equality holds if and only if A1 over B1 is equal to A2 over B2 up to AN over BN. We can prove it by writing modulus of A1 plus A2 up to AN in this way and then applying the CS inequality. And we get what we wanted. That's it. Hopefully now you are convinced that T2's lemma is nothing but the another version of CS inequality. Let's try out a problem to demonstrate the use of T2's lemma. Let A, B and C be positive real numbers such that ABC is equal to 1. Prove that 1 over A cube into B plus C plus 1 over B cube into C plus A plus 1 over C cube into A plus B is greater than or equal to 3 over 2. Ask yourself how to manipulate this expression in order to use T2's lemma nicely. Recall the statement of T2's lemma and think. If you want, you can pause the video. We can write it in this way. Now we apply T2's lemma and we get this inequality. Now we have the sum of three ratios is greater than or equal to BC plus CA plus AB upon 2. Now what? What should we do next? Can we find the value of BC plus CA plus AB? The answer is no. We are given only the value of ABC, and from that there are infinite possible values of BC plus CA plus AB. If we are able to minimize BC plus CA plus AB, then we will have some hope. But how to minimize it? Yes, you are thinking right. We have another deadly tool in our arsenal that we call AMGM inequality, which can give us the rescue, and by using it we reach the destination. So this was a nice problem which nicely combines two popular inequalities, Cauchy-Schwarz inequality and the AMGM inequality. All you need to solve such problems is imagination that comes through practice. If you want to learn CS inequality in detail and want to practice a lot of problems with great variety, our book Algebra Volume 2 is a good resource for it. The links are in the description. If you do not know, let me tell you that our books are written with such great efforts that we have given all the relevant theory in detail in a deductive way, with proper reasons and explanations. We don't preach, we deduce. That is how the math is evolved. So reading our books might be a great experience for you, like you are experiencing this video. Like me, if you find the CS inequality, the delicious one, write down the word delicious in the comment section. This will prove that you are not the pretender and you are serious to learn some good math. And we let the pretenders confuse why the heck everyone is writing this strange word. Next week we shall prove the CS inequality, and also we shall see one more version of CS inequality that we will call the triangle inequality, and we shall solve couple of challenging problems. Thank you for watching this video. See you next week.